Hello, my dear children of class 12 science. Today again I welcome all of you through this mode of teaching, and today we start the last unit. The last unit as per reduced syllabus, okay, sent by the council, okay, and this is unit number 9. In fact, this is as per the class 12 syllabus is concerned. Unit number 9 is not the last unit, but as per the reduced syllabus we are following, this is the last unit. Okay, so unit number 9 is the last unit that we do. Basically, in this unit there are two chapters that we deal in details, and the unit number 9 is called electronic devices. Electronic devices, and the first chapter we do is called semiconductor electronics. So as I said, only as for reduced syllabus only we do two chapters, and this chapter are not long chapters. Okay, one is semiconductor devices, and after this we do PN junction diode. Okay, so that are the chapters. These are the chapters that we deal in unit number 9. To start this chapter, we just do with the introduction of the classification of material. As most of the material can be placed into two classes. Okay, and these are nothing but conductors, and another one is called insulator. Okay, the conductors, okay, and insulator have just opposite property. Okay, and insulator also called bad conductors. Sometimes we call insulator also as what conductor? Bad conductor. Bad what? Conductors. Now, out of these two classification, like one is conductor and insulator, also called bad conductors, we know that what is conductors. The conductors are those material, or we also call substance, through which electric charge can easily flow. Means those substances or material where the electric charge can easily flow are called conductors. Okay. Now this conductor usually actually have what? Large number of what? Free electrons. Yes, children, you have learned this concept of free electron in the chapter called electricity also, current electricity also. Okay. The conductor has large number of what? Free electron, and free electron are the electron which detach out from the outermost orbit and move freely in the space between the ions. Okay. Ions of a conductor, and that electrons are called free electrons. And due to large number of free electrons, these electrons, free electron, actually act as a what carrier? Charge carrier. Means current conduction is basically takes place in a conductor due to this charge carrier, and this charge carrier in conductors are nothing but what electron? Free electrons. But you know that every conductor has resistance. The resistance of conductor is usually less, but resistance of a conductor depends upon the temperature. But usually you know that when temperature increases, resistance increases of a conductor. So for every degree rise in temperature, there is a resistance of conductor increases. So that's why there is a factor that can always measure. This factor is called temperature coefficient of resistance. And temperature coefficient of resistance is always positive for conductor. Now why temperature coefficient of resistance is positive? As you know that when temperature increases, resistance also increases. So that's why that decrease in resistance, the change in the resistance with the increase in temperature is always positive. And this change in resistance per unit original resistance per degree rise in temperature measure the temperature coefficient resistance. And remember this, children, for conductor, temperature coefficient resistance always what? Positive. Conductor also has conductivity. Okay, the conductivity means the ability to allow the charge to flow. Now conductivity of conductor is usually high, but this conductivity can even increases. Conductivity can even increases with the rise in temperature. When temperature rises, conductivity increases. But there is another factor which decreases: resistivity. You know, you have learned this term, resistivity or specific resistance, opposite to conductivity, because conductivity and resistivity are reciprocal to each other. And resistivity of conductor depends upon the temperature, but resistivity decreases with the rise in temperature. Means the ability to obstruct, okay, create some obstruction to the flow of charges decreases with the rise in temperature, and ability to allow the charge to flow in the substance increases, that is called conductivity increases with the rise in temperature. So this is nothing but a substance like conductor. And you know there are many examples of conductors, okay, like silver, copper, okay, aluminum, okay, etc. So I just add etc. like that. There are so many conductors, and basically metals are usually conductors. Okay, so this is the substance which we know it is called conductor. Now there is another substance, as we know, which has just opposite property to conductor, and they are called insulators. Now insulator are another substance, as I said, and this substance has just opposite property as conductors. Now insulator are those materials through which electric charges are difficult to flow. The charge cannot flow at all in an insulator. As you know, why? What is the reason that charge cannot flow in an insulator? As you know that there is no free electrons to flow in an insulator. That means insulator has almost no free electrons present in the insulator. Okay, so when there is almost no free electron present in the insulators, okay, then this free electron cannot flow throughout the substance. Okay, so and those substances or material which does not allow the charge to flow at all is called insulator. They are called insulator. Now insulator, there are many examples of insulator, or as we call as bad conductor also, and common example like rubber, plastic, wood, etc. These are the example of what? Insulators. These are the example of what? Insulator. However, between conductor and insulator, there are certain material. There are certain material whose conductivity is intermediate, or it lies between the conductor and insulator. Now, in a simple way, I tell you that conductor has large conductivity, where the insulator has almost no conductivity. Okay, why conductivity is no conductivity? Because has large resistivity. So I just add resistivity is very large. Resistivity is very large. Very what? Large. While conductivity is negligible. While conductivity is what? While conductivity is negligible, means almost no conductivity. Okay, but even between this conductor and insulator, there are the material or substances whose conductivity lies between conductor and insulator, and we call this material or substances as semiconductor. We call as what? Semiconductor. So children, we can simply define semiconductor are those material whose conductivity lies between conductors and insulator. Okay, and they are called semiconductors. Okay, now in case of example semiconductor, we have example also. There are many semiconductors, okay, but we discuss only the few and most commonly used semiconductor, and the semiconductor are nothing but like carbon. Carbon is a semiconductor. Silicon, it comes under silicon semiconductor. Okay, and even I add one more, that germanium. Germanium are the example of what? Semiconductors. So these are the most commonly used semiconductor, and due to this semiconductors, devices like semiconductor devices are also be made. And due to these semiconductor devices, okay, we are advanced in the technology. So why the technology advance is due to the number of semiconductor devices which has been developed, okay, which has make our work life very easy. Okay, so that's why the advancement of technology is also due to the semiconductor devices which has been developed by number of scientists, okay, that we see using in our day-to-day life. Okay, but commonly used semiconductor are carbon, silicon, germanium and all. Now basically this semiconductor, substance like semiconductor, have a valency 4. So valency 4 means they are also called tetravalent element, and this tetravalent element usually form a compound by sharing the electrons. Okay, by sharing the electron, and this sharing the electron usually form what type of bond? Covalent what? Bond. Now even if you see the valence electron, and you know valence electron in an atom is also called the outermost electrons. The outermost or valence electron in semiconductor are not rigidly bound with the atom as in case of insulator, and even not loosely bound as in case of conductor. That means the valence electron present in the electrons or semiconductors are not loosely bound as compared in case of what? Conductor, and also not tightly bound as in case of what? Insulator. Okay, so with this, usually what happens when the temperature increases? The resistance and the resistivity of semiconductor decreases. Now usually you know what happens when there is a rise in temperature. Okay, the conductivity increases. The conductivity increases means more electrons, free electrons can, more electrons, balanced electron can detach out from the outermost orbit and become free. So the number of free electrons in semiconductor increases with the increase in temperature, rising temperature. Due to that, what happened? The conductivity increases. But when the conductivity increases, as you know, resistivity decreases. So remember, children, that in case of semiconductor, resistivity decreases or conductivity increases with the rise in what? Temperature. So children, when temperature increases, resistance decreases. And when there is a decrease in resistance and the resistivity which also decreases with the increase in temperature, the temperature coefficient of resistance of semiconductor is always what? Negative. Because with the rise in temperature, instead of increasing the resistance, like you saw in case of conductor, the semiconductor resistance decreases. Okay, when resistance decreases with the increase in temperature, definitely the temperature coefficient of resistance always become negative. And this is for what? Semiconductor, which is just opposite to conductor. That's why if the temperature of a substance, semiconductor, becomes absolute zero, say minus 273 degrees Celsius, at absolute zero temperature, even the semiconductor may becomes an insulator. What insulator? Ideal insulator. Because at this temperature, there will be no resistance of the semiconductor. If there is no resistance of the semiconductor, means definitely what happened? Definitely what happened? I'm so sorry, I just made just opposite point. As the temperature decreases, resistance increases. So just let me do the correction out here. As I said, when the temperature increases, resistance decreases, and when the temperature decreases, resistance increases. Now absolute zero means a very, very low temperature, minus 273 degrees Celsius. That means when you decrease the temperature, the resistance increases, but the resistance of the semiconductor become almost infinite, or very, very large, with absolute zero temperature. So under this absolute zero temperature, the semiconductor even may becomes ideal insulator. Means ideal insulator means the insulator having a very high resistance or resistivity, because insulator has very large resistivity and resistance. That means that semiconductor can also becomes an what? Ideal insulator. But this is possible at absolute zero temperature. So these are the classification of material basically into two types, but conductor and insulator. But between conductor and insulator, as I said, there are the substance whose conductivity lies between conductor and insulator, and this substance we learn in details as what? Semiconductors. Now in the next video we try to understand the energy band in solids.